This is Professor Derived Classes. This is part 3 of the Java inheritance tutorial. In part 2 we looked at the base class, the boat class. In this part we'll be looking at the derived classes, the canoe, motorboat, rowboat, and sailboat. This is the code for the canoe child class. The keyword extends with the class that's the parent, boat, is what connects the child class canoe to the parent class boat. Canoe extends boat. That means it is everything that boat is, but it might do more and might do some things differently. So when we look at canoe, we want to see what it's reused without any change at all, what it's overridden to provide specialized changed behavior from its parent, and what things are new. Looking down through the code, we see that there's a canoe category. It's final. It's a constant, and it just has the word canoe for the category. There's a new field also, number paddles. Canoes have paddles, and the default value here is 1. That's your basic canoe. Canoe has a constructor that uses the same parameter signature as its base class. However, its base class constructors are not inherited. The way you initialize the base class fields, as we see here in this constructor body, is through use of the super keyword. Super needs to be the first line in the constructor, and it makes a call to the base class constructor, and the parameters that you give it is how it matches up which constructor in the base class to call. So the first thing that happens when a child class is instantiated in its constructor, the base class constructor is first called to construct that part of the child. Because even the private fields from the parent are part of the child. The child cannot directly access the private fields. It can access them through the getter functions that have been made public or protected, or through setter functions also to update them. So you call super to initialize those data members, and then you have your own constructor code here. And what happens here, the category protected field in the parent is being changed to the canoe category, effectively giving this boat, this canoe, a new category name. Next, we see the multi-parameter constructor that matches the parent class constructor. There's the call to super, passing in the 4 parameters, and then again the category is set to the canoe category. Display specs has code very similar to the parent. However, this, in this case, refers to the canoe object itself, and it's going to call the toString function in the canoe object that we'll look at momentarily. If we look at the annotations over here, one of them says, do we want to add the override annotation? Again, the purpose of that, which we're not going to do, would be to guarantee that this display specs name and parameter signature would always have to match the parent function that it's overriding. In case somehow this got misspelled, there would not be that unnoticeable subtle error in there. So you could add that to enforce that, to guarantee that likeness through the compiler. The other annotation here simply says that this method does override a method in its parent, which is boat. draw a side view. Similar annotations. Notice that a canoe has a paddle there on the side. The top view, the default is for one paddle, and that's the display that it displays, just one side paddle. You'd have to switch it to the other side with, you know how you row a canoe. You want a couple of dips over here and a couple dips over there. Going on down, we have a getter, a get function for the number paddles, and also a set function with some validation logic to protect the state of the child. That for a canoe, the paddles, you have to have one or two. It won't allow more than that in a canoe. The toString down here, notice that the toString first calls its superclass toString, which is the boat class, the minimal hull boat, to get that into a string, and then on the end of that it adds its own specifications, the number of paddles here, and returns that as a string. The annotations here are the same annotations as we saw on the other ones. Moving on to the motorboat. The motorboat, another child of boat, extends boat, has its own category. It introduces a field, horsepower, an integer, to represent the power of its motor. It has the same two constructors that we saw in Canoe, but of course for itself, and it has to call super as well to initialize the parent fields. Again, we see the same pattern of override, display specs, draw a side view, draw a top view, and a toString that again calls the parent through super and adds on its own specification. Next, we'll look at the Rowboat, extends boat, has its own category. It defines number oars. Rowboats have oars, and default is 2. One oar on each side of the boat is your minimal rowboat. Two constructors that both call super, the parent. Same overrides, display specs, side view, top view. We see here the drawings for a rowboat from the side and from the top with the oars here. The two backslashes are, of course, when you have a string and you want to show a backslash, you have to double it so that it will interpret it as a backslash and not as a backslash something else that has special meaning. Down here, the toString again calls the base toString and then tacks on its own number oars and returns that, and that's what gets returned up here to this print line here with the this, which turns into this .toString. The last child class, sailboat, a similar pattern for the sailboat, and we see it has a nice side view and top view for the sailboat. Very parallel designs for these 4 derived classes. Finally, looking at the client that exercises the child classes, boat derived client as a main method, and instantiates a rowboat named Swanee and calls display specs on it, draw a side view, draw a top view, a canoe called Mohican with parameters, changes its hull material. Notice this, that the constructors did not actually take as a parameter the hull material for this class here, well, for any of them. So they call the setter to change it, just reducing the number of constructors used in these simple classes. Similarly, calls set number of anchors through a setter to change the number of anchors here. In the in this particular in the Canoe, we'll have 0 anchors, so that's why that was set. Fiberglass canoe with 0 anchors. Display the specs. Draw a side, draw a top. The motorboat is going to be fiberglass, 20 horsepower. The sailboat, fiberglass. The height of the mast will be 25. So constructor and then some setters. Let's go ahead and run this. See what we get. Scroll up to the beginning. There's our rowboat called Swanee, category rowboat. Its parameters, including the number of oars, number of anchors, side view, and those were tacked on to the base specifications up here. As you see at the end, the number of anchors, well, that was a base one, but the number of oars was tacked on to the end down here. There's your views of the rowboat. Then we get the canoe called the Mohican with its side and top view. There's a motorboat. It was called Purple Haze. It has a horsepower of 20. There's the motorboat side view with the motor, top view of the motorboat. And finally a sailboat called Spirit with a mast height of 25, side view and top view of the sailboat. So we see here in the output the physical differentiation of the boats through their specifications and through their drawings, and the reuse of their parent fields that are automatically supplied to them with the getters and setters. This concludes our 3-part inheritance tutorial.